Graphing quadratic equations. Today in class we learned about the importance of the vertex when we're graphing parabolas. And so we're going to want to make sure that we identify the vertex is going to be x equals, let me get that on the screen, x equals negative b over 2a. And I also told you in my class that it's often just more beneficial to put the negative with the b and put it over 2a. So now let's go ahead. We're going to do example number 2 from class. So we have our vertex, starting with our x value, equals negative b over 2a. So we're going to plug it in. So bring your negative down for that piece right there. Now ready for the b. The b here is negative 4. So don't forget to keep that negative in front, but there's my b value. All of that's going to be over 2 times a. A is here, the invisible 1. So now I have negative, which is positive 4. Then 2 times 1 is 2. So 4 divided by 2 is 2. So the x value of my vertex is 2. To find the y value, we can plug it into this initial function. So y equals my x squared. So I'm going to plug the 2 in place of the x. So 2 squared. And then I have minus 4 from up here. Now I need it to multiply times x. So I'm going to again pull up that 2 because I just found out x was 2. And I still have this plus 1. So this function right here matches the original, except wherever there was an x, I put a value of 2 in place of it. And now we're going to clean this up. So 2 times 2 is 4, and then negative 4 times 2 is negative 8, and I still have plus 1. Add all that together, 4 plus 1 minus 8 would be negative 3. So my vertex is going to be 2, negative 3. The axis of symmetry is the line, and it's going to be a vertical line, one that goes up and down, where it would cut the parabola directly in half. So the axis of symmetry is going to be an x equals equation, because that's how you get the equation of a line for a vertical line. So x is equal to this value here, 2. And now we're ready to make a table. When we make a table, you have x and y here. And the vertex always goes in the middle, 2, negative 3. And then you're going to pick some values that would be both left and right of it on the number line. Now notice the values I picked. Notice that 1 is 1 unit away from 2. 3 is 1 unit away from 2. We want to keep these so that they are equidistant from our vertex value. Same thing with the 0. 0 is 2 units away from 2. 4 is 2 units away from 2, so 0 and 4 are both equidistant from the 2. That makes a difference because when we start plugging this into the calculator, then we start to get some information that helps us with both of these numbers. So now, you can use a calculator, you can do this longhand. I'm actually going to scratch out number 5 here and just keep working on underneath it. But my original equation was y equals x squared minus 4x plus 1. And I'm going to be doing these different values into that equation. So starting with the first one, y equals, I'm going to replace all the x's with 0. 0 squared minus 4 times 0 plus 1. So y is equal to 0 times 0 is 0, minus 4 is 0, plus 1. So y equals 1. So for 0, I get a 1. Then we do this again. We're going to do this for, let's go ahead and do the 1. Y equals 1 squared minus 4 times 1 plus 1. So I'm going to get 1 squared is 1, 4 times 1 is negative 4, and then I have plus 1. So that right there, when I add them together, is going to give me negative 2. And then when I plug in both 3 and 4, doing the same method here, the 3 and the 4, I'm actually going to get the following numbers. You can check it by plugging them into a calculator. But the reason I wanted to make sure that the numbers were equidistant from the vertex, like the 0 and the 4, is so that these numbers would match. And if I do this in the calculator and I find that these numbers don't match, then I know I did something wrong and I need to start looking at my work. Now that you have the table, we're going to go ahead and plot the table here. So we have 0, 1, then we have 1, negative 2, we have 2, negative 3, we have 3, negative 2, and we have 4, 1. And what this makes is a U shape. So you're going to want to make sure it looks more like a U than it does a V. Put arrows at the end, and then that's the parabola. That axis of symmetry where x equals 2, if I put a dashed line here, that represents the axis of symmetry. which means that if I were to cut along this line right here, it cuts my parabola directly into two symmetrical pieces, or into two equal pieces. So this is the basic concept behind graphing a quadratic equation. So step number 1, again, start with x equals negative b over 2a and find your x. Then use the x value, plug it into the original to find your y. That information provides you information about your vertex. So step number 1, you find your vertex. Then you take your vertex and you plug it into the middle of the table and pick values for x that are equidistant from that vertex. And then once you plug all that information into your calculator and get your values, you're ready to graph. Don't forget to state your axis of symmetry, which will be an x equals equation. X equals the value of the x in the vertex.